Hey guys, so we're looking at 6b.5. I can prove triangles are similar by applying the correct similarity theorem. So now we're kind of doing a hodgepodge of, you have to know, am I going to use angle, angle? Am I going to use side, side, side? Am I going to use side, angle, side? Okay. So how do I know which one to use? We use angle, angle when I know two angles of both triangles. Okay. Easy enough, I know two angles. Side, 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 I know all three sides. Of both triangles. Side, angle, side. No, at least two sides, right? And the angle between them. Right, again, between them. Or you can use angle theorems to find it. That works for this too. No two angles of both triangles. I don't know what I'm doing there. Again. Or can use angle theorems. So our angle theorems are all the things we learned in V1. Right? We have our angle theorems include vertical angles, corresponding angles, and the triangle angle sum theorem. So if either of those apply for the angles, then that works for angle, angle, and side, angle, side. Okay. So let's look at just a bunch of examples for these. Okay. So again, we're determining if the two triangles are similar. If they are, write the similarity statement and explain which theorem you used. Okay. So looking at example 1, I have this triangle here, 7.5, 5, and an angle, and then 12, 8, and an angle. Looking at this problem, I have two sides and one of my angles. Which of these am I going to use? I know at least two sides and the angle between them. Looks like I'm going to use side, angle, side. Okay? Easy as that. So my smaller side over my smaller side. And then my bigger side divided by my bigger side. And this is one place we do have to be careful. 8 divided by 5. I just get 8/5. Twelve divided by 7.5. I get 1.6. Well, one's a fraction, one's a decimal. So all I'm going to do is I'm going to convert 8 divided by 5 to a decimal. I'm going to go to menu. Number 2, convert to decimal. Oh, look at that. I get 1.6. Okay. Go away. So, okay. So yes, that checks out. Okay. Then, do I have my angle between them? Yes. Angle B and angle E both have one little arc mark. So angle B is congruent to angle E. Okay. So now I'm going to write my similarity statement. So, triangle. No, it want me to change colors. Triangle A, B, C is similar to, well, A was between the line and nothing, D. B was my circled one, so E. And then C is the one that's left, so F. Right? Again, be careful with your naming. By, I use side, angle, side. Okay. All right, example 2. What can I say? Well, I know 2 angles on this triangle. I know 2 angles on this triangle. So the first thing I can say is angle A is congruent to angle C. That's just an easy one. Well, now I need to solve, right? I don't know if these are similar because this is 27, this is 28. So I'm going to solve, let's solve for angle E. It doesn't really matter which one you solve for, either one would work. I'm going to solve for angle E. So I have x plus 28 plus 125 has to equal 180. 28 plus 125 is going to be 153, right, equals 180. And then I'm going to subtract 153 from both sides. So x equals 27 degrees. Ooh, that's nice because D is also 27 degrees. So now I can say angle D is congruent to angle E. Okay. Well, now I have an angle and another angle, so I can write my similarity theorem. So triangle ABD is similar to triangle A was 125, so C. B wasn't circled at all, so in this triangle B is also not circled. And then D was my blue one, E. Alright, so triangle ABD is similar to triangle CDE by, what theorem did we use? Angle, angle. I used 2 angles there. Alright, looking at example 3, what do I know about this triangle? Well, with this triangle, right, I have 1, 2, 3 sides, 1, 2, 3 sides. Okay, so I know 3 sides of both. So I'm going to be looking at side, side, side. So starting with my small side, smallest, 11 over 22 has to equal middle. So 20 over 40 has to equal large, right? Or biggest. 21 over 42. Again, 11, 20, and 21 all come from the same triangle. 22, 40, and 42 all come from the same triangle. Okay. Reducing my fractions, 11 over 22 is 1/2. 20 over 40 is 1/2. 21 over 42 is 1/2. So, triangle. I'll go again in alphabetical order. A, B, C is similar to A is between the circle and the line. Circle and the line is F. B is between the circle and the square. Circle and square gives me E. And C is between the square and the line. Square and the line is D. So triangle ABC is similar to triangle FED. By, what did we use? We used side, side, side. Alright, looking at example 4. Again, this is one where I know 2 angles on both triangles. So I'm going to look at angle, angle. Well, none of these are congruent yet. Let's solve for E. See if I get anything there. So I have x plus 37 plus 15 equals 180. When I add 37 and 15, I get x plus 52 equals 180. Then I'm going to subtract 52 from both sides. When I do that, I get 128 degrees. that's still. So I have no angles congruent to anything here. So there's really not much I can say. There's nothing congruent, nothing equal. So these are not similar. Nothing really more than that. All right, let's look at our next example. Looking at example 5. Remember, these little lines are showing me that these two lines are parallel. As soon as you have parallel lines, you are looking for your corresponding angles. Okay? So, all right, as the parallel line runs here, it's this angle and this angle. So, angle AEC and BDC. Then I have my other set always, our corresponding angles always come in that pair. So angle EAC is congruent to angle DBC. Okay. So now I have my two angles. So I can write that is angle, angle. So I'm going to write my similarity statement. Triangle AEC, I'm doing the big triangle first, is similar to triangle. Well, AEC, well, A goes with B, E goes with D, and C goes with itself. Okay. By angle, angle, right? Because I use two angles there. All right, looking at our next example. Again, I already have one set of angles here. Angle T is congruent to angle V. What else can I say? Remember, anytime you have this two triangles kind of touching, right, those lines, you get those vertical angles. So angle TUS is congruent to angle WUV. So again, I can't just say angle U because I don't know which part of U I am talking about. So I have to name it with all three. All right. Looking at our similarity statement, triangle. I'll just say that TUS is similar to triangle. Well, T was my 51, so V. Then U was my vertical angle, U was my vertical angle, and then W was the angle I didn't use. By angle, angle. All right, two more. Example 7. All right, I have all three sides for this one. So, smallest is 4, smallest is 2.5. 4 divided by 2.5 has to equal middle, 7.2 divided by 4.5, which has to equal largest. So 4 divided by 2.5, by 2.5 is 1.6. (7.2) by 4.5 is 1.6. And then 8 divided by 5. Ooh, a fraction. I'm going to change it to a decimal right away because I know the other two are decimals. So number convert to decimal. And again, we get 1.6. So those all look good. So these are similar. So we're going to do triangle A, B, C. A is between the square and the line. Square and the line gives me D. B, square and circle. Square and circle gives me F. And then C is between the circle and the line. Circle and the line gives me E. And for this one, we use side, 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 right? We knew all three sides. All right, our last one, we know our two sides. So I'm going to start by checking if those are proportional. So I have 6 smallest divided by smallest has to equal my large divided by my large. So 6 divided by 13.5. Wow. Is 0.444 dot dot dot, right? It went on forever, repeating decimal there. And then 8 divided by 18, again, that's a fraction, so I'm going to change it, go to number, convert to decimal, and I also get 0.44. Yay. So I have my two sides. I want to look at the angle between them. Well, the angle between them both have that little right angle mark. Okay, so again, those are equal. Angle B is congruent to angle E. They're both 90 degrees, right angles. So I have sides, my sides, and my angles between them. So these are similar. So I have triangle ABC is similar to triangle. A between the line and nothing is D. D was my right angle, so E. And then C between the circle and nothing, so F. Okay. And for this one, we use side, angle, side. All right, sorry that one was a little bit longer. Go ahead and work on the activity.